Today in Math 10C, we're going to look at how to solve a system of linear equations algebraically. Now, we can solve them by graphing the two equations and finding the point of intersection. Or today, what we're going to look at is we can solve for one variable and then substitute it into the other equation. That's called the substitution method. This creates a new equation with only one unknown, and by solving this equation, we're going to be able to solve for the other unknown variable. The other algebraic method of solving a system is using the elimination method. This starts by adding or subtracting these two equations to try to eliminate one of the variables. So let's get started. Let's solve this system of equations using the substitution method. Well, the first thing that we're going to do is look for something that we can solve for easily. And in the first equation, x can't be solved for very easily, neither can y. But in the second equation, we can see that it should be fairly easy to solve for y, because if we added 4x to both sides, we would get y is equal to 4x minus 2. So look for something easy to solve for. And it looks easiest to solve for y in the second equation. And when you took the negative 4x plus y equals negative 2, adding 4x to the left and the right side rearranges the equation to say y is equal to 4x minus 2. Now, what we're going to do with this is substitute it for y into the second equation. The first equation. So we're going to substitute this in the other equation. You can't substitute it back into the first equation, otherwise you'll end up right where you started. So when we go 7x plus 3y is equal to 51, we'll say 7x plus 3 times 4x minus 2 equals 51. Now I can solve for x. If I expand and simplify this, I'll get 7x plus 12x minus 6 equals 51, or 19x minus 6 is 51. I can add 6 to both sides, and 19x will equal 57. Dividing both sides by 19 will leave me with x equals 3. Now I found that x equals 3. So I'm going to continue by plugging 3 back into one of the other equations. And I can plug it into any equation now. This will allow me to solve for y. Well, I already know that y is equal to 4x minus 2. So if I plug in a 3 for x, I'll get 4 times 3 minus 2, which is 12 minus 2, or 10. So the solution, algebraically, to this system of equations is going to be x equals 3 and y equals 10, or we can say it's the ordered pair 3, 10. Don't forget, you always have to verify that those are the solutions. In number 2, we're going to solve this one using the elimination method. So if you notice now, I have x plus 3y is 11. 2x minus 3y is equal to 4. If I added these two equations together, I could eliminate the y's. That's where it gets the name elimination method. So if I added these two, I'm going to get 3x plus no y's, or 0, or nothing, equals 15. No more y's. I can divide both sides by 3, and I'm left with x equals 5. At this point, I'll plug it into one of the equations and figure out what y is going to be. So that will be x plus 3y is 11, or 5 plus 3y is 11. Take away 5 from both sides, and divide both sides by 3, we get y is equal to 2. So our solution is the ordered pair 5, 2. In number 3, it asks us to solve this linear system by elimination. Oh, don't forget to verify. Well, this time I don't have anything that's the same. I don't have the x's the same, I don't have the y's the same, but if I multiplied both equations by different constants, I can make something the same. And so what I'm going to do is I'm going to try to make the x's the same. If I multiplied my first equation by -3, I could get -6x's. And if I multiplied the second equation by 2, I can get +6x's. You also have to multiply the 7y by -3 and the 24 by -3. You also have to multiply the -2y by 2 and the -4 by 2. So there's my two new equations. Now if I add these two equations, I'll eliminate the x's. That'll leave me with 25y, or -25y is -80, and dividing both sides by -25, I'll get y is 3.2. Substitute that back into one of the equations, and I'm going to find that x will have a value of 0.8. There you go. Number 4. Solve this linear system by substitution. Well, first of all, I'm going to notice that it's a mess. So the first thing we're going to do is clean it up. Expand and simplify everything. So that'll give me 3x minus 6 plus y is 7. Or if I cleaned it all up, I'd get y is equal to -3x plus 13. It's pretty easy to put it in terms of y at this point. In the other equation, if I cleaned it up, I get 4x minus 3y plus 3 equals 16. And I'm going to take away 3 from both sides. Now I can substitute and put the -3x plus 13 in there for y. And I'll get one equation with one unknown. And that'll work out to 4x plus 9x minus 39 equals 13. Cleaning everything up, bringing the 39 over to the other side by adding 39 to both sides, you get 13x equals 52. Dividing both sides by 13 leaves me with x equals 4. Plugging that back into one of my equations leaves me with -3 times 4, or -12 plus 13, and y is equal to 1. First of all, let's move on to 5. Create a linear system to model this situation. Alexia invested $1,800. Part of it was at 3.5%, so we're going to let x be the part invested at 3.5%, and the rest at an annual interest rate of 4.5%. So we'll let y be the part invested at 4.5%. After 1 year, the total interest was $73. So let's make two equations. The first one is going to be about the money. And the money invested is going to be x plus y equals a total of $1,800. The second equation is going to be about the interest earned. And the interest earned is going to be the part invested at x, which is 0.035x, plus the part invested at y, which is 0.045y, has to add up to $73. So now to use the substitution method, we're going to forget about that. We're going to say, I want to use the elimination method. It's easier. I'm going to times the second equation by 1,000 to get rid of all of the decimals. And I'm going to multiply the first equation by 35 to make the x's the same. Now I can subtract these two equations to eliminate the x's. So the second equation I'm going to write first. That's allowed. And I'm going to subtract, so I get positive numbers. And when I subtract these two equations, you get 10y is 10,000. Dividing both sides by 10, and y will equal 1,000. So that's now your answer for y. Y is the part invested at 4.5%. But since x plus y is 1800, y is 1000, you can figure out pretty easily that x is 800. Be careful here that you just don't move off until you answer the question. And the question is, how much money did Alexia invest at each rate? So you have to say that Alexia invested $800 at 3.5% and $1,000 at 4.5%. Let's move on to 7.6. This is determining the number of solutions to a system of equations. Well, a system of equations is going to have one solution if the two lines cross and they intersect at one point. This will happen if they have different slopes. Two lines will have no solution if they're parallel. That means that they have the same slope, but they have different y-intercepts. Let's look at some equations. If I said y is equal to 2x plus 3 and y equals negative x plus 9, you'll notice that these two have different slopes. That means they're going to intersect in only one spot. The second equation, for the second problem where it has no solutions, would be something like y is equal to 2x plus 1. The second equation would have to be y equals 2x, has to have the same slope, plus 3, let's say, so that it has a different y-intercept. So we can summarize that by saying they're going to be parallel lines, same slope, different y-intercepts, no solution. Thirdly, infinite many solutions. Infinitely many solutions means that these two lines are going to coexist. They're going to be what we call coincident. One line lies on top of the other. That's what that's going to look like. And in this case, will only happen if the two lines are the same equation. They might be in a different form. For instance, they might be y equals 2x plus 3 and 2x minus y plus 3 is equal to 0. Here's the same equation, but in two different forms. They're going to have the same slope and the same y-intercept. In the first one, it says determine the number of solutions of each linear system. X plus y is equal to 3. Negative 2x minus y is negative 2. Let's rearrange this and put these equations in slope y-intercept form. In the first equation, we would take away x from both sides and y is negative x plus 3. In the second equation, we're going to add 2x to both sides, multiply everything by negative 1, and y is equal to negative 2x plus 2. Notice that they have different slopes. As long as they have different slopes, they will have one point of intersection, one solution. Let's move ahead to the second one. 4x plus 6y is equal to negative 10. Rearranging this, y will equal negative 2 over 3x minus 5 over 3. And the second equation, dividing both sides by negative 3, gives me negative 2/3 x minus 5 over 3. And since they have the same slope and the same y-intercept, we must have an infinite number of solutions. The two lines are the same. Thirdly, if we rearrange this one, negative 4y is negative 2x minus 1. Divide both sides by negative 4, and you're going to get y is equal to 1/2 x plus 1/4. Second equation, negative 6y will equal negative 3x plus 2. Dividing both sides by negative 6, y equals 1/2 x minus 1/3. So this time, they are going to have the same slope, different y-intercepts. This means that they're going to be parallel. Therefore, no solution. Well, that summarizes Chapter 7. Your homework is to do page 452, numbers 1 to 21 as a hand-in assignment.